Good morning, learners. Greetings for the day. I, Venkata Phani Babu, I have pursued my MTech from JNTUH in the field of AMS, Advanced Manufacturing Systems. Welcome back, learners. As continuation to our previous session, this session we will be going with diagrammatic representation of a lathe, how it will be looking, what are the different parts, what are the different specifications, what types of lathes are there, and how many different types of operations can be done on lathe, right? So as the figure shows you, this part in this direction a operator will be standing. So for the general definition of an operator means, or operator is defined as a easy position for a man or for a person to control all the controlling units or controlling levers such that it will be in handy. That is, operator should always be placed such that he can easily control all the levers of a machine. So right from starting, as I am saying, that if the operator will be standing at this place such that at the left of his there will be headstock, right side it will be tailstock. So this headstock will be called as live center and this will be called as dead center. So why we are calling it as live center? See, this live center we will be having all electrical controls, that is the power tools will be here only, all power will be connected here only. Why we are calling it as dead center is, here there won't be any power operated things until unless we will be mounting some extra accessories only. As far as center lathe is concerned, or as far as this diagram which is being seen, it doesn't have any accessories. So we are calling it as live center at the left of the operator, then dead center at the right of the operator. Now coming to each part, as I said, see, if you clearly see this hole, in this only we will be inserting chuck key such that it will be tightening the work holding devices and the workpiece will be kept here. So coming from I will be starting at center from this way, I will be rotating this way and I will be discussing with each part, right? So this part is called as apron, it is also called as carriage, on which we will be having cross slide, then we will be having compound rest. Above the compound rest there will be a tool post. Here the tool post will be used to mount the tool, and the tool will be in a fixed position in the lathe. So then this was the check where our work holding device will be there. There are different types of work holding devices. In later slides we will be discussing that also. Then coming to the power tools, that is operating tools, spindle speed selector, that is high speed, low speed or medium speed. Then headstock assembly will be there, in which there will be a chart for different manufacturing units saying how many gears are there, or what are the gear ratio, or how many gear ratios can be achieved by using different types of gears. Then coming to down, there will be a feed selector, then there will be a clutch such that to operate it according to the speed. Then this chip, and this is also called as tray, which when the shearing happens from the workpiece, and all the chips will be collected at the chip tray. As I said that this is apron, or also called as carriage, right? So coming to this split net is a mechanism where this whole apron is being connected to the lead screw, this lead screw. So that later on for the operations why this split net, that is half net mechanism, is used, we will come down. And these levers are used for longitudinal and transverse feed control for the total apron. This is the feed rod, and this is lead screw, which will be having fixed pitch of a screw. Then this is the bed, this is coolant motors. Coming to left side, that is, this is called as dead center. This dead center will be always called as tailstock also, and it will be having with a hand wheel, then it will be having a quill, it will be having a revolving center, free revolving center. On below this tailstock there will be bed on which it can be slided this way or this way, that is towards the live center or towards the end of the bed. So the main parts coming to a center lathe, that is this bed, headstock, tailstock, carriage, will be always depending factors to specify a lathe. These are the main 4 parameters, or we can say as main parts which can decide a lathe specifications. So coming simple sentences for the important parts. Bed, it always supports all major components of the lathe. Then coming to carriage, it slides along the ways, consists the cross slide, tool post and apron. As I said, apron, full apron assembly is called as carriage. It will be having a cross slide, it will be having a tool post, and it will be slides along the ways. That is, here we will be calling it as ways, in the sense it is guide ways only. Now coming to headstock, holds the jaw for the workpiece, supplies power to the jaws and have various drive speeds. So supplying power to the jaws and has various drive speeds, in the sense it is live center, right? That is power controls. And headstock is also having a provision to hold the jaws for a workpiece. Jaws, in the sense we will be calling it as checks, right? So headstock is not only power control, it also have work holding devices. Coming to tailstock, it supports the other end of the workpiece. If suppose from live center or headstock to tailstock, there was a lot of gap in between. So when a long suppose if you take a bar of 2-3 meters length, so what happens is, when it has been supported with a single cantilever support, the whole weight will be trying to get downwards. So for support, to remove this type of disadvantages, tailstock is introduced such that it supports the other end of the workpiece and it will be in same axis only. Feed rod is provided by a set of gears from the headstock. So why gears are used? Gears are used for transmission of power. When there are different drive speeds are being allowed in headstock, automatically these gears will be used to change the drive speed of the feed rod. Now coming to the principle, as we have discussed in the last session also, principle is rotating workpiece with a fixed tool. So it holds the workpiece between 2 supports called centers. What are these 2 centers? That is headstock as well as tailstock. Live center or dead center. So chuck or faceplate is used for work holding devices. That is, this will be at headstock and also called as work holding devices, right? Chuck or faceplate is mounted on machine spindle. Since we are saying that rotation of workpiece will be there, it will be mounted on machine spindle. Cutting tool is held and supported on the tool post, because tool post it will be supporting at the other end, support for the other end, that is support to end of the workpiece. Movement of the job is rotation about the spindle axis. A tool is fed against the revolving work, because tool is stationary here, right? Movement of tool is either parallel or at any inclination of the workpiece. So why we are saying inclination? See, tool is either parallel to what? Spindle axis, or it may be at any inclination of work axis. This inclination of work axis is achieved for having different operations, right? We will be discussing what are the different operations. We will be discussing it. See, as I said, at the headstock there will be a work holding device. These lathe chuck types are work holding devices for that. So if you see here, there are different types: magnetic check, 4-jaw independent check, combination check, 3-jaw universal check, collect check, drill check, air or hydraulic operated checks. So magnetic check, it will be always having a permanent magnet in it, and here a simple disadvantage is the workpiece should be of only magnetic material only. So 4-jaw check, this first jaw, second jaw, third jaw, fourth jaw. These 4 jaws are operated individually with a check key. If I want to get this jaw towards the center, then I will be operating only this, and if I want this jar to be moved towards center, it will be operated separately. Coming to combination, it will be magnetic as well as individual checking. Hydraulic checks, it will be operated with hydraulic, and this 3 jar, it is also called as universal check. This 3 jar check is mostly it will be used for 90% of the operation, such that this is also called as eccentric jar. Since all these 3, that is first one, second jar, third jar, these 3 jars can be operated simultaneously with only one hole. In this hole, if you insert a check key and if you start rotating it clockwise or anti-clockwise depending upon the workpiece fitting, these 3 jars can be moved simultaneously. Like this it will be moving. If these are the 3 jars and there is a check key being used, so depending upon the rotation it will be closing or it will be opening it out. So coming to 8 jar, it will be pneumatic and color jar and also drill check. Sorry. So as I said, important part was headstock. So this whole section will be giving you a different view when compared to assembly figure, and this is called as engine lathe headstock. So in this there will be levers for using for getting different speeds. There will be a reduction gear, that is the ratio for high and low. Then there will be a feed shaft reverse. Then also we will be having a forward and reverse switch. We will be having feed gear levers. We will be having metric to inches conversion. Then we will be having feed shaft change speeds. Then we will be having a lead screw. Then we will be having bed. Upon bed we will be having guideways. Upon that we will be having a removable gap. Then there will be a clutch provided in the headstock. Then there will be a main shaft spindle. In here, a chuck will be always connected to spindle. So it is mounted on left hand headstock. As I said, headstock, it is always mounted at the left end of the bed. That is, when the operator is standing in front of a lathe machine, his left will be headstock. It carries a hollow spindle. It is also called as live center, and it can be attached to the spindle. The spindle nose is threaded outwards such that it can be attached with a chuck. The chuck or a face plate can be attached to the spindle such that the rotary motion of the spindle is transferred to the chuck. The headstock may be back threaded type. The headstock has 2 types of driving mechanism. It is back gate as well as belt driving mechanisms. These 2 can be utilized according to our machining parameters which we decide. So another part is tailstock, right? So tailstock will be like this, and it will be having a handle such that the projection can be moved towards the headstock. Normally this in this diagram we have used a drill chuck to be supported. So in between this, see, if this is the workpiece, for the other end support, this drill chuck will be inserted at the it is touched to the workpiece such that it will be at a simply supported beam. So it can be moved along the sideways or guideways on the bed. It can be clamped at any at any location on the bed from headstock to tailstock. Inside tapper to hold drill chuck. So here there will be inside tapper such that this drill chuck or revolving center can be fitted automatically. See, this is drill chuck separately. So as we are saying that inside this hollow we will be having a tapper section, right? So this tapper section will be attached with most tapper of the drill chuck. Then this most tapper and this tapper will be giving a good fit for the drill chuck. So coming to the specifications of lathe. So there are 8 to 9 types of specifications, where first specification is according to the heights of centers, then bed type, that is straight or semi gap, then at the center distances. Center distance in the sense it is eye center and dead center, that is headstock and tailstock. Then the second point is swing over the bed, swing over the cross slide, swing in the gap, gap in front of the face bed. This swing comes because we are using cylindrical type of workpieces. Third is spindle speed range, that is power ranges, spindle nose, spindle bore, tapper nose. Then coming to metric thread, lead screw pitch, longitudinal feeds and cross feeds. Next is cross slide travel, top slide travel and tool selection. Next one is tailstock, sleeve travel, tapper in the sleeve bore. Seventh is motor, that is power, input power, right? Depending upon the horsepower and RPM of the motor. Then shifting dimension, that is the shape and dimensions for the lathe machine, that is, it depends upon LBD. We will be calling length, width, height and weight of the machine. So next one is, as we said, carriage, right? So this comes in between of headstock as well as tailstock. Okay, carriage will always move along the bed between tailstock and headstock. So this is the area where it moves, only this area. Okay, saddle is nothing but apron, where everything is fitted on it. Then apron hangs down in front, that is, here operator will be there, and it hangs down such that it will be easy to use this lever, even the power levers which are at the headstock. Even we can utilize tailstock levers also in the same manner. So here for the apron or carriage, we will be having different operations in this. Automatically it can, as we said, if you remember in the last session or in the last slides, we said that half nut mechanism, split nut mechanism. So this split nut mechanism will be directly attached with the lead screw, such that this whole movement of a carriage can be automized automatically from left to right or right to left, depending upon the spindle rotation. If spindle is rotating clockwise, then apron will be moving in clockwise, that is from away from headstock, vice versa for the both. So coming to cross slades, as I said, there will be inclination for the tool also. See here, this is somewhat inclined when this is the axis, right? So it is fitted, cross slide is fitted to saddle, and it moves the cutting tool at right angles to the lathe bed. So even for at any inclination, if this was our axis, we can directly at right angle we can go, or with a inclination, or this side inclination from 0 to 90 degrees we can go. From it ranges from 0 to 90 degrees, we can change it. So top slide we will be calling as this one, top slide. So this is also called as compound slide. It is fitted on top of cross slide, carries tool post and cutting tool, can rotate to any angle. It is mainly used for turning tappers only. So in this, what is the main thing is, here we will be using feed shaft. We will be using feed shaft and also a lead screw. These two, feed shaft and lead screw, will be mainly utilized for turning tappers. So coming to tool post, this is a single one machine, one cutting tool can be mounted, that is a single tool post we will be calling, and this one is multiple tools can be mounted on this. So one tool can be mounted like this, another tool like this, another tool like this, another tool like this. So simultaneously 4 can be utilized, but it depends upon the length of the machine tool, cutting tool, which we will be mounting on this. So it will be having a locking lever such that it cannot rotate at all, and these small screws are utilized such that these tools will be rotated downwards onto the shank of the tool, such that it will be fitted perfectly and it won't be moving while a machining operations can be done. Even the cutting tool holding part will be also having a locking screw, such that this can be rotated downwards such that it touches the shank, and when we fit it, there won't be any movement of the tool. So it is fitted on top side and carries cutting tool or the cutting tool holder. It can be adjusted according to the type, depending upon the lathe types, and it can this tool post can carry 4 different types of tools, and this can carry only one type. So coming to the cutting tool materials, there are different 5 types of materials which we can be used. We will be using carbon steel mostly, and for general cast iron and MS we will be using HSS tools. Then we will be using satellite, then we will be using carbides and diamonds, which are harder materials. So coming to carbon steels are very soft at 180 degrees, and the limitation means that the tools are rarely used for metal cutting operations, and it is widely used for woodworking, and they can be used to rotor aluminum sheet up to about 3 to 4 mm thickness. Coming to HSS, they are also called as high speed steels, and they can be operated at higher speeds. They are tough and suitable for uninterrupted cutting and for complex shapes of drills like reamers, taps, dies and gear cutters. This may be coated for having more wear resistance. These HSS tools may be coated such that it can give more wear resistance. Coming to satellite, it is a non-ferrous alloy of chromium as well as cobalt, so hard, and it cannot be forged, and it should be machined except by grinding. It is usually used for tip tools, general tip tools. Coming to carbides, they are also called as cemented carbides or sintered carbides, which have high hardness over a wide range of temperatures, and these carbides will be having good high thermal conductivity. They can be shaped only by special grinding wheels and is always used in the form of a tip tool. So both satellite and carbides are used for tip tools. Coming to the diamond, it is the hardest known substance, right? So it is used for light uninterrupted finish cuts at almost any speed and is mainly used for high speed machining only. For aluminum, silicon alloys, composites and any other non-metallic materials, these diamond tools can be used. Line diagram, where we can simply remember the main parts of it. See, the circle part, this circle part is apron or a carriage, what we are calling it as a carriage, right? So it will be having tool post, it will be having cross slide, apron, the saddle as well as compound slide. This compound slide can be rotated in order to get tool inclined position, any desired angle positions, right? So coming to headstock, headstock is also called as live center, as we said, right? Then coming to our right side, operator right side, there will be dead center. It is also called as tailstock, and this is called as lead screw, and this lead screw only by using the half nut mechanism, this whole carriage will be connected to lead screw such that we can gain automatic movement for the apron such that it moves towards headstock as well as it can move towards the tailstock depending upon the rotation of the spindle, right? So we know about bed, we know about feed shaft and base. So coming to different operations, what all operations we can do by using lathe. So we can do phasing operation, we can do straight cylindrical operations, we can do shouldering, we can do filleting. The filleting can be done by form tool only. So what type of fillet you need, that type of cutting tool has to be mounted on the tool post. Then coming to radius turning, this is also about form tool only. We will be using form tool only. Even necking of workpiece can be done by form tool only. Taper turning, here the cutting tool will be inclined to the axis. And external thread cutting, that is outside cutting, and forming. And coming to next slide also, we will be having different. We can give knurling, we can do facing, we can do parting, that is cutting, making into two pieces. We can drill a workpiece, we can drill a hole in the rotating workpiece. We can ream the drill workpiece. We can enlarge the drill hole, that is called as boring, and we can even give internal threadings for a workpiece. So hope you understood everything till now about the lathe machine. So in during next sessions we will be trying to discuss with another machine tools which will be very easy for you yourself, for self learning at your own pace. Thank you for your time.